This is like the external face of all the AI that Northeastern is doing, not only in computer science, but also electrical engineering and 8 other colleges, because the AI is used in many, many applications. And we believe that experiential AI means that we are in control of things, not in the loop, and also that we have responsible solutions. And for that, we need better algorithms instead of just putting more data. So we have also responsible AI practice where we work with top companies on principles, AI governance, bias audits, and anything related to how to make AI better. So why responsible AI? Maybe you have heard about ethical AI. Well, ethical AI doesn't exist. Things like ethics, justice, trust are human traits. So we cannot associate ethical to a machine. The same for two hallucinations. You need to understand the word to do that. So that's a semantic mistake when we use these words related to language models. I guess also you have heard about trustworthy AI. Sadly, the European Union and National Science Foundation have programs that use this term. And this term not only has the previous problem that trust is something human, but also that we know that AI doesn't work all the time. So why are we asking the users to trust AI? So we put the burden in the user instead of putting the burden on the creator of technology. And that's why we use responsibility, although that's something also human. Because of law, we can apply responsibility to institutions that, for example, commercialize or put this in the public domain. Now, there's a kind of paradox because people want AI to be better than us, but they're learning from us. And there's a very interesting book by Cesar Algo and collaborators that shows that humans judge machines different from judging humans. So to err is human, but for machines it's not. So I will start in the first half with responsible AI, because if we don't know what are the problems, we don't understand how we need to basically regulate or change our development to solve these problems. So this is my own taxonomy. These are the main problems for me. So the classical one is automated discrimination. This is the most typical one, but we also have pseudoscience and fair e-commerce. I will not be able to talk about this, but basically here we have exposure bias, popularity bias, and all the products in the head get richer while all the others get poorer. Waste of resource, so the environmental impact, and also we have the human incompetence in many ways. You can see that all of these are human incompetence, but in some cases just pure human incompetence. Now with generative AI, we have 3 different new things that are important. There's information. This was important before, but now it's amplified many times. We have the copyright problems when you're using data that doesn't belong to you. And finally, we have mental health that I will talk later. We are seeing the beginning of that. So if you take one of the the best database so far of incidents, which is called incident database of AI, you can get this graph on the number of incidents that have been happening from 2010 to today. So you see that this is increasing. Oh, I hope it's not an exponential curve, the beginning of an exponential curve, but it's at least linear. Remember that when a technology gets used a lot, the problems with that technology will grow at least in the same way. Now, with the new AI regulation in the Europe, we have these risk categories, and it's very hard to measure risk. But let me try to do a first approach to what are the problems. So if we say that this is the risk, for example, 0, no risk, 1, very high risk, and the impact, and here we have billions of people, 5 billions are the people that have access to internet, maybe this will be like the current landscape. It's just an approximation, it's my own thinking, this may be wrong, surely have my own biases, but one important thing is that I think AGI has risk 0, but if that happens, it will affect everyone. Now, the first problem, as I mentioned, was discrimination. And typically that comes from biased data. Now, any information has bias. The problem is that we think bias is something negative, but in principle is neutral. So in the rest of the presentation, I'm talking about negative bias, because also there is positive bias. Now, should an algorithm do something about negative bias? Well, should be neutral, should be fair with respect to whatever society wants from that algorithm to output. Typically, this question is never asked, and then you get the same bias. Worse, in some cases, you get amplified bias. If you get amplified bias, you cannot blame the data. You have to blame the algorithm. So here I make a distinction between data bias and algorithmic bias. Algorithmic bias is a bias that is not in the data, it comes only from the algorithm. And this is what is exposed in this vicious cycle I explained of bias on the web. 2018, bias is also on the, for example, optimization function, and bias is also in the feedback loop between the user and the system. Now, let me give you an example that will show this amplification. This is a paper I like a lot. It's by Kleinberg, Leskovec, and very well-known people in computer science, and was requested by the National Bureau of Economic Research of the US, not by the Justice Bureau. So they took 750,000 cases of bail from New York State, and they showed that if predictions of the model were correct, they could decrease the crime rate in 25%, keeping the same number of people in jail, or they could decrease the prison rate in 42%, keeping the same crime rate. Even worse, if the predictions are correct and you take the 1% most dangerous criminals, more than half never appear in court, and also more than half reoffended. But this was a case of bias amplification. So let me give you only one table of the main results. Here, this is not in the paper, but I put the demography of New York State. It's 18% Black, 13% Hispanic, so in total 32%, these two minorities. Well, these are the defendants. Already to court was 92%. So this, you can see this is the systemic bias, police bias, and more. Well, what about the judges? Well, the judges increased the percentage of Black to 57% and diminish a little bit Hispanics, 32%, maybe because they are white Hispanics. But in total, you increase to 89%. Well, the best model learned that bias. And this is a bit amazing because the only demographic attribute that the model had was age. If you're interested, they used gradient boosted decision trees because was not enough data to use neural networks. Now, the good thing about algorithms, we can tune them. And if you take, for example, the lower rates for both ethnic origins, you can reduce the percentage to 80%. This is less bias than, let's say, the system bias, but it still is more than twice the proportion. So now we have a question. What is better, to use a bias algorithm that is just because for similar cases will take the same decision, or a noisy judge? What happens with judges? Judges really don't take the same decision for the same type of cases all the time. Depends on the mood, depends on the context, depends on many things. I was using this very interesting paper of Harvard Business Review that shows that the inconsistent decision-making of humans has a very high cost. In many cases, could be worse than bias, especially for the business. But now this question is a fallacy question because really we need to compare C, these are algorithms, they are biased, with D, these are judges, they are biased and noisy. So in some sense, in this kind of applications, an algorithm could be better. But we'll get back to this because we haven't looked at the ethics aspect of this. Now, 2 years ago, Daniel Kahneman and co-authors published a book only about this, Noise, a Flaw in Human Judgment. But this can be much more complicated. During 2020, during COVID, maybe you remember this news, an algorithm predicted the grades of students. Of course, public students got worse grades than private students. And the average is true, but in practice it's not. There are good students everywhere. So this was not used because it was discriminating poor people. It's another interesting case. End of 2020, a group of riders of Deliveroo, platform to deliver food, found that they were discriminated. They didn't know why. because they didn't have same skin color, same gender, or any other attribute that would explain this. Still, at the end, the judge found that they were discriminating, and the reason was very simple after you know it. People that couldn't deliver at night got less work because most of the demand is at night. So, for example, women, people with kids, and so on. This was illegal because you don't need to work at night in Italy and most countries. And here we have a fundamental ethical question. Why data from other people can be used to predict your behavior, especially if there's no data about you? So basically, you can argue that your own data can be used to predict yourself, but there's no science that shows that you can do it for other people. That can be really bad. And this started more than 10 years ago in Netherlands with a system called CIRI, CIRI with a Y because it means Systems for Risk Indication. And it happened because some people abused of the system and basically got this child care benefit for their own interest, but not for real reasons. So someone said, okay, we need to look for fraud in this benefit. And this is the first ethical issue. You shouldn't look for fraud in poor people. You should start with rich people. So this system forcibly accused most of these 26,000 families, and they had to return many, many years of subsidies. 42% of them were immigrants, so this was the largest population, minority that was affected. Well, after 5 years, the civil society sued the government, and this was interesting because even agencies, the Data Protection Agency of Netherlands, 2014 said don't do it. And finally, 2019, the state secretary resigned. And in 2020, the court in Netherlands said that this was illegal and they had to be compensated. The government decided not to appeal. That was good. But then after a parliament commission, clearly the impact was much worse than expected. And January 14, 2021, the leader of the opposition resigned. This could be surprising, but what happened is that he was the Ministry of Social Affairs during the beginning of this case. One day later, the whole government of Netherlands resigned. So basically, this system, this badly made system that also was, in some sense, biased to immigrants, basically got rid of all the politicians in Netherlands. So let's go to the second problem, pseudoscience. I don't know if you know what physiognomy is, but basically this is a theory that says that depending on your face, you have different personality. Let me give you some examples. In 2017, famous Stanford psychologist presented a paper where he said that he could predict your sexual orientation based on your face. Of course, this was not science. It was just spurious correlations. Even before, two researchers in China said that they could do criminal detection using faces, basically Minority Report if you saw the movie. Of course, this was pseudoscience again, and it's not ethical either. But in 2020, I guess people forgot about this paper in China that still you can find in archive. And this paper from an American university all got published in a Nature journal. Again, this is not science. Finally, 2021, Kosinski came back with another paper that says that you can predict the political orientation from your face. Now, for example, if you use things like hair, if you have a beard or not, and so on, maybe you can infer a few things, but that's nothing to do with your face. So we're seeing something like modern phrenology. If you don't know what is phrenology, it's an idea that started at the end of the 18th century in Germany that proposed that criminals had different convolutions in their brain. And this was simplified. So this is the second best museum in Torino for me, is the former house of Cesare Lombroso, which simplified the theory basically to say that the skulls were different. So skulls of criminals were different, and he collected hundreds of skulls from the morgue from poor people. And he really believed this because he left his skeleton as ground truth. for what a normal person should look. A normal person that collected hundreds of skulls. But this can be worse. Now, MIT published this paper in a very good computer vision conference in 2019. Send me a voice message and I will reproduce your face. I may believe that my mouse or everything below my mouse has to do with how I speak, but for sure not the rest of the face. So this is also pseudoscience. Even worse, last year, this patent was granted to Mitre and basically says that given your name, also they can get your face. So now if you send me a voice message with your name, I can produce your face, and now using the previous pseudoscience, I can predict if you're a political opposer, illegal sexual orientation, or if you will be a criminal. But this can be more subtle. A couple of years ago, Lisa Feldman Barrett, a very famous neuroscientist, showed that humans cannot predict emotions. Basically, we just rediscover stereotypes. Most people, when they laugh, they're happy, but it's not always the case. And because we use that kind of data to train AI, AI basically does the same, to rediscover stereotypes. Let me go to the third one, incompetence. 1976, a famous statistician said all models are wrong, but some are useful. This is the case of today's AI. More sophisticated models, but still they are approximations of the world. Let me give you some examples. At the end of 2020, Elon Musk said, use Signal. Of course, he was talking about the chat app, but some software in the stock market that use data from influencers, so that he was saying that they should buy from this company in Texas, Signal Advance, and this company went up in more than 400%. The company was very happy. The people that follow the trend did not. But then you have to ask what these models learn. This is an example of adversarial AI, where you change one pixel and a dog becomes a cat with 76% confidence, or a cat becomes a dog with 78% confidence. So the question is this good? Well, people don't do this. And this other example may be funny, but it's not funny if the town is using this Facebook page to, for example, announce COVID issues. So what happened? A Facebook engineer decided to use an English-trained toxic classifier and decided that the town of Biche was forbidden, was a bad word. And also the town had to wait 3 weeks for someone hear their complaints. So there was no human in the loop. So let me here remember the limitations of machine learning. We are very good, humans are very good at filtering information. And here I'd like to remind this amazing short story from Borges, Funes de Memorias. That was a person that couldn't forget, and then he couldn't summarize anything. You cannot learn what's not in data. Yeah, this is obvious, but you have to remember it. Also, that data doesn't capture everything. This happens in 2018 in Arizona, when a woman in a bicycle crossed a road in the wrong place, and a self-driving car didn't recognize her. Well, what happens with this kind of data? Well, most data is in the future. We still not have all the actions that we may want to have in our training data. We will get back to this case because it has other problems. So we also have an evaluation problem, because accuracy is not what matters. Imagine that you go to a pharmacy and you ask what is the side effects of a drug, and the person there says, I don't know. This is what is happening today. We don't know what happened when it's not working. And this is what's really important, the impact of errors. Currently, accuracy assumes that all errors have the same impact, and that's never true. For example, false negatives might be worse than false positives in medicine, or false positives might be worse than false negatives in justice, for example. So for the computer scientists in the audience, please, if you're not sure, if the confidence is low, don't output a result. Just say, I don't know. That's what smart people do. And here we have the concept I'm working with some of my PhD students of non-human errors. For example, this was the first person that died in 2017 from a self-driving car. Basically, the Tesla autopilot didn't recognize a white truck with a cloudy sky. Or, for example, you will never block an emergency vehicle. Cruise, here, all the red ones are Cruise in San Francisco, block many, many emergency vehicles. Or, for example, you will never believe that if you have a cone in your hood, you cannot ride. These are non-human errors. These are things that AI does that humans will never do. And here you have all the cases of problems in San Francisco that finally it stopped. So let me give you a real ethical dilemma. I'm sure some of you know about the trolley problem, but forget about that problem. You will never have it in your life. But let's say a real problem with self-driving cars. These are all the people killed by cars. You don't need to convince me. Much less people were killed by self-driving cars. What is the problem? The problem is that they will kill some people that before were not in danger of dying. And these people, maybe we will save irresponsible men, and we will kill, for example, a kid crossing very fast the street to take a ball, or a very old person that basically was walking too slow and in a panic moment didn't move. Ethics is personal. So let me give you 3 quotes. This is from Voltaire. Basically, this says that one false positive is worse than one false negative. And all people will agree with that. However, a few years later, a very famous judge in England said that it's better that 10 guilty persons escape than one innocent suffer. Only a few years later, Franklin went to 100 persons. And even he said that no one basically complained about this. So basically everyone agreed with him, I guess because it was him. But here is the possible spectrum, 2 orders of magnitude between 1 and 100. The fourth problem, environmental impact. For example, this comes from the very famous stochastic parrots paper, where you can see that training a very small transformer, 200 million parameters, is like 57 years of the carbon footprint of average human life on Earth. And also, for example, you spend between $1 and $3 million in electricity. Now, the truth is that what is really bad is the billions of people using the model every day. And there was a paper last year that showed that every time you use ChatGPT, you waste like half a liter of water. I don't know why they don't use TikTok for this, because maybe it's even worse. With ChatGPT, I guess you are doing something useful. And then we come to generative AI. So generative AI is like a Pandora box. We are really funding now all the problems that this will produce. So if we do a pseudo-personality profile, you can think that it's a very fluent, confident, it's naive, will believe everything I say. And if really the hallucinate, it's incoherent and drunk. But also we have bias issues, hate issues, censorship, everything we don't see, especially in topics where we don't agree, or for example, the US has a different view than Europe. Lack of diversity. It's mainly trained on American text right now, the ChatGPT-4. And not talking here also about not understanding all languages. 15% of the people don't talk the languages that are supported by ChatGPT. And finally, loss of skills. How many of you cannot find a place with the GPS without the GPS? The same will be true in the future. Maybe you will not be able to write, but it's not about writing, it's about thinking. I'm sure you saw this last year. Very well done. Now it's getting worse. This is the year of deep fakes. More than 17 countries have elections, and we will see the impact of these technologies much more than before. One problem is copyright. I guess you saw end of last year, the New York Times suing OpenAI, but this is not the first. The same happened before, like February last year, to Stability AI from Getty Images, and so on. There are more than 3 cases right now in the US courts. And this is the end of digital truth. So very easy to basically take your voice, take your videos, and then I can do whatever I want with what you want to say. This is an example that was in the Congress of the US, where a mother told the Congress how they use a fake voice of her daughter to believe that she was abducted. And it's very easy to use. There's a sad case in Spain in September, where basically teenagers faked naked pictures of their own classmates. And of course, the system is not prepared for this, and people don't know what kind of crime is this, especially if teenagers do it. So now anyone can do this. There is a very recent case, like this week, where a Hong Kong company lost $25 million because a person believed that he was talking to many important people, and all the people in the online meeting were faked. So basically, they were able to reproduce the video and the voice of many people, and the person believed that, and then he did a transfer that was not right. But then we get to mental health. And started with the case of Jessica. This is like 2021, when a person used GPT-3 to recreate a dead fiancé. So every time he was sad, he will chat with the ex-fiancé. Is this healthy? Who knows? But last year, this person did it with even video and voice for his grandmother. Anytime he wanted to talk to his grandmother, he would go and talk to this avatar, was using ChatGPT for the text and Midjourney for the video. And then very recently in China and in Texas, they reproduced 2 famous psychologists, basically by fine-tuning ChatGPT with their work. Is this what we want? Well, depends. In March 23, Jaron Lanier, one of the fathers of augmented reality, said the danger isn't that AI destroys us, it's that it drives us insane. I thought that he was completely right. This is the real problem. People believing that they're talking to humans when they're talking to machines. Well, he will never expected that 5 days later, he will be proven right. A PhD student in Belgium committed suicide after 6 weeks of talking to a chatbot. And I will let you read the last conversation that was found by his wife. He had a wife and 2 kids, but he preferred to talk to a chatbot or to a professional. And this is the last conversation. Yeah, this looks like a scary science fiction movie. And if you see at the end, there's the understanding that after the death, they will find each other in the afterlife. So yes, he had mental issues, but probably with professional, the final result will not be his death. So this is not new. It started in 1966 with Eliza. Eliza was the first chatbot, and this was the first conversation published in the paper by Weizenbaum at MIT. And he was the first AI person that basically said that we were in danger. And this happened like more than 30 years ago. So we're just seeing the revival of all this, because we must never confuse computers with humans. So when the first part, this is the important message. And for example, what's wrong with this image? Well, robots don't think. So don't use these images where robots are mimicking human expressions. So language models do not hallucinate, they make errors, they don't think, they mimic conversation, Of course, they don't have opinions, but they reflect those. They don't have intentions, but they do produce outcomes. And although they don't intend to manipulate and do harm, they do cause manipulation, misinformation, and harm. So what we can do? The best ethical principles are the ones coming from bioethics. They are autonomy, the respect of human dignity, everything related to harm and benefit, basically do good and don't do bad, the basis of all religions. And finally, be just. Try to give opportunities to people that have less or have some vulnerability. And the problem comes when these principles conflict. For example, I need to reduce your autonomy to avoid that you harm yourself, or even worse, you harm others. The first regulation in place is one in China last year. I should include it here, on generative AI. It's the best regulation on generative AI I have seen, particularly because they believe misinformation can put in danger their own political regime. So what about the European proposal? Well, now includes generative AI has taken more than almost now 3 years. Probably will be voted in March or April by all the countries. Was already the parliament, sorry, the European Parliament. They need to vote again, although they voted in June, because the text changed. And the first question is, should we regulate the use of technology? We are doing an experiment. This is the first time we do it. And this will be like regulating the use of a hammer. You shouldn't use a hammer to basically hit a person. I don't think this is the best way to do it. We should regulate the problems, not the technology. Because then we need to do for any usage of technology in the future. But this is done too late. We need to try this experiment. The second problem is what we are regulating. Is only AI systems or any system? Do we have an AI loophole? We need to check the final wording of the European Union to see if this covers any automated system. And it's very important because the last problem appeared last month, and maybe you have seen it in the news. January 1st, private TV in the UK streamed this series, 4 chapters, about Mr. Bates against the post office. Well, this was not an AI system. This was just a badly done accounting system that had data issues, especially with data corruptions. And only Mr. Bates went to court against the post office after 900 people were falsely accused of basically keeping money from the post office. Now, in his case, he was able to basically go to the system and at the end found that 39 of these 900 were innocent, but all of them were innocent. And this was really a pity because 4 of them committed suicide. And even though the last year the government wanted to compensate them for people that went to prison because of this, they were not happy with the compensation. And this was not really known in the UK until this TV series, which says something about current media. And the last problem with the EU Act is this risk-based categorization. And we have done it many times in our history. Races is the same. Someone decided that the skin color was discrete. We have discrete values, and we invented these things about race when skin color is a continuous value. Risk is the same, and we have invented forbidden cases that only by example, not by definition. And then we have 2 risk levels, high and low, and then by default, no risk. But why we don't have middle risk? It's really a boundary between high and low. What is the boundary between high and forbidden? This is very hard. We are, again, in a very complicated zone created by our own cognitive biases. Well, in the White House, they started in 2022 with this blueprint for an AI Bill of Rights. But something very important, they put here, making automated systems work. So they're saying AI, but they are saying this for any automated system, so this is good. This doesn't have the AI loophole that I was mentioning before. Now, these are basically the 5 principles. These are instrumental principles that are a bit basically obsolete. And this was a pity because we published in ICM just 3 weeks later the new ICM principles, which are much better. Well, but the US keeps moving, and in October 30, 2023, Biden issued executive order on safe, secure, and trustworthy artificial intelligence. And very few days later, well, 1 day later, they launched at NIST the AI Safety Institute, and we will see this year more actions from maybe several states regarding how to regulate the use of AI. So these are the new principles of the ICM. These were the old ones from 2017. These are the new from 2022. I am one of the main 2 co-authors of these principles, and I'm very proud that the first one that I push, this is legitimacy and competence. Basically, you need to show that the application is legitimate for society. So basically, the benefit is much larger than the harms. And also, you need to show that you have the competence to do it well. Because if you do it badly, then you have problems as the ones I have mentioned before. Also, it's new, everything's generally new. We say explicitly, you need to minimize harm. You need to worry about harm. And because some people believe harm means human harm, we put 9 explicitly. It's not only about humans, it's also about the impact on the planet. So basically, for me, one important regulation will be for anything that will impact the lives of many people, you need to do an risk impact assessment to check for human harm and for environmental impact. So this is the governance. So before, if you see, there were no clear order of these things. In particular, the transparency was here in the title, but was not in the principles, and no one noticed. The order is also important. These things happen in certain order, and number 1 is the first because it's the one that you have to use first. So when you have the idea, you need to do this ethical risk assessment or human rights assessment, whatever you think is important for your case. Then during design, development, operation, you need to do validation and testing. You need to have monitoring tools to check that everything is working as intended. And here comes maintainability. For example, what happens if the distribution of the input changes? What happens if the accuracy of the system changes, and so on? And if it fails, then you need contestability and auditability. And here you have to do an algorithmic audit. We have done those. These are not easy, especially if you don't have the cooperation from the company or the model being audited. And finally, when it harms, there's nothing to do. You need to go to court, but here is when you need accountability and responsibility. Very important, never audit an algorithm that is not legitimate, because if you do so, you are legitimizing the algorithm. And this already happened. And even was a paper, in fact, about an audit that was basically successfully on gender bias, but legitimized the use of other techniques to do whatever the algorithm was doing. And here we have to go to accountability. So who is responsible in the Uber accident? Well, Uber was not responsible because they reached a settlement with the family of the woman killed very fast. No one knows how much money, probably millions, were paid to not be accountable. But they also, at the same time, they informed the Arizona state that the backup driver in the car was watching a video. And then Arizona had to basically charge this backup driver of manslaughter. Manslaughter. This is kind of very sad because only 4 years later, she decided to give the first interview on Wired, very interesting interview. She was a transgender woman from Mexico, immigrant, minimal salary, doing a very boring job, and it failed. And she failed too. She's responsible too, but it's not fully responsible. Also over is responsible, but nothing happened. And last year, she declared herself guilty, and she will be basically in house arrest for at least a year with these rings in her ankle to make sure that he doesn't get out of home. So at the end, the accountable person was the most vulnerable person. So this is our responsible AI scheme. We're reorganizing this, but basically we look at governance, we look at ethics analysis of products or projects, and we also do the training, because if people doesn't understand how to put the concepts in operation, this doesn't work. We also have the first independent AI ethics advisory board that we launched in 2022. And basically, these are almost 50 experts from all over the world, from where you can get advice for tough AI ethical AI ethics issues if you need so. Of course, these are private advice. Now, this is a multidisciplinary challenge. It's not only about computer science, it's also about design, social sciences, ethics, law, and policy. So there are many questions, and remember, computer scientists shouldn't be answering questions where we are not qualified to answer. So to end, we need to basically be aware of our own biases and ethics. This is the most important thing to start. And if all systems try to empower people instead of replacing people, we will be much better than today. This will be like my second part of the revelation. Very simple. Your goal should be to empower people, to improve productivity, to make people better, not trying to cut cost and replace people. And of course, you cannot have AI ethics without ethics, and that's part of the problem we have today. We don't have ethics in most things that are happening in the world, at least in people with power. So we'll finish with two kind of half jokes, half truths. Although I guess this is a full truth, I'm not concerned about AGI. I'm concerned about the decrease of natural intelligence. This is the problem today. And if that's the problem, I think it's worth asking this question from a robot. Can humans think? And we're interested. I published last year a paper where we have a summary of this presentation. Thank you.
Thank you very much. So I would like to ask anyone who has questions to basically ask the question. And I can start by two questions. So first of all, I agree with what you said at the end about ethics. So it's not that we have coded the ethics that should be followed in the society, and also by these by different artificial intelligence solutions. So since they're not coded, it's also very hard to train these artificial systems to abide by them. So there is a gap, I think, there.
Yes, right. So we need to include these principles in the way we develop software. So that's why I put this governance, because this is the way at least to be thinking on this from the beginning. There's one attempt from Ben Schneiderman, very well-known person in HCI. He published a book last year on basically how you do human-centered AI. And he approaches, he suggests some solutions to parts of the problem. But we need more than that. So we need software engineering that basically is responsible by design. So we have privacy by design, but we need to have responsible by design. And this is something new. I guess some people started to work on this, but for example, there is a paper, and they mentioned this because there are so many things that are interesting here, the paper that shows that, for example, the biases of the developers get transferred into the code. So it's not only when you design, it's by chance when you program, you also are putting your biases there. For example, I always kind of half joke, half true. I would love to see a recommender system done only by women. I'm sure will be much more empathic than the current system that we have today that are basically trying to look how we can spend more money on them. So yes, there's a lot of work, and I believe that AI should help AI. So this is the next step, how AI will help to have responsible AI. I saw a question about if the algorithm had access to the ethnicity. The answer is no. That's why I said the only demographic variable that the algorithm had was the age. But the algorithm was, the model was able to infer the ethnic origin from the data of each case, and also from the outcome of the judge. Because if the judge is racist and the outcome shows that, then basically the system will be able to learn that. So basically that was learned from, in some sense, from correlations that you have on the data with the ethnic origin of the person. Of course, if you have names and addresses, that correlation is much more high and easier. But no, the only thing was age. Not even the gender was given, because almost all these people were men. But not even that was given to the system.
You also spent quite a bit of time talking about governance legislation. So these new efforts coming up both in Europe and in the US. So how will that translate concretely to companies that develop these solutions? So if I am developing such a solution, how will these legislations change things for me? So what additional steps will I have to go over?
Yeah, I have seen, I haven't read completely the final version, so I don't have a complete answer, but I know that, for example, if you have a high-risk application, you will need to fulfill several requirements before deploying that solution. So you will need to do things. And if you have a low-risk application, will be more like a self-regulated thing. So basically, you will need to do things, but basically no one will check those until I guess you get into trouble. And here we have a problem, because if you do your own self-assessment of what is the risk of the system, we have a conflict of interest. You always will choose the one that is low. So for example, a low-risk system will be a no-risk system. A forbidden system will be a high-risk system. And of course, a high-risk system will be a low-risk system. So we will see this tendency to understate the risk because they don't want to comply with the regulation. Now, the easiest thing will be to say that I don't use AI, because if the regulation is only for AI, that's what people will do. Will say, I'm not using AI, I'm using very sophisticated statistics, very complicated formula, but it's not AI. And it's very hard to argue that it's not AI. This could be true. So typically, you cannot go and check the code of a person and what they are doing. So these things have very little transparency. That's why they're called black boxes. You cannot check what they're exactly doing. And not even people that understand very well neural networks know how they really work at the end, because they're so large that it's impossible to understand what they're doing.
More concretely, so if we assume that a new system has to not be biased, for example, so how can a developer assert that?
Yeah,
Or
good question. So first, I don't believe that there's a system that is not biased. So I think unbiasing is impossible, because in many cases bias is hidden until someone finds the problem. And this is the problem with people too. People is not aware of biased actions until maybe someone points out that for example, a word is biased or an action is biased. So basically, you mitigate bias, and you mitigate the bias that you know. So the first way to do this is there are already some say, benchmarks to check for some of these bias, for example, gender bias, ethnic bias, age bias, so all the typical demographic bias. There are some tools from companies and also some open source from universities that you can use to check for those. The problem that typically you will have some maybe intersectional bias. These are the ones that are more hidden. For example, imagine that the problem is old Black women. These are the problems. So you cannot check for all possible intersections that you have in your data set because that grows exponentially, right? so you need to try for the most important ones, for the ones that may, for example, may affect more people or may affect people that may sue you, because at the end, always the incentives are the ones that depends on the impact. For example, could be that you need to check all the biases that may imply a fine from the government. So you're basically depends on the punishment. You will do the categorization of what to do. But I think if you do this ethical risk assessment or the impact risk assessment I mentioned, at least you can say I thought about the possible harm of the system. And basically, I'm not fooling myself. I believe that risk is minimal and the benefits are much larger. Let's say like vaccines, like COVID vaccines. Yes, some people died, but compared to the people that saved, the ratio might be 1,000. So this is what I'm saying. And I don't want a ratio 1,000, but I think you need to have a ratio at least between 10 and 100 if you see the quotes from very famous people in the 18th century. This is what I mean. But today, in many cases, people do these things just to basically try to get money very fast, but they're not thinking in the consequences. And there are many examples today that I did mention about, for example, loss of reputation because of not thinking on these basic things. I mean, how the system can, for example, how a system can be used in the wrong way or in the bad way. How I can mitigate the possibility of that happening. These are the questions which we should answer. And I do have another version of this talk that is called the 10 key questions that the company should ask. This is the starting point. This is like a rubric of 10 questions. And for example, last year, and I want to include this result in this presentation, very interesting paper about predictive optimization, that they have a rubric of more than 30 questions where you can ask yourself about your system to see if you are basically doing one of, I think they have eight problems that are more like scientific problems with your problem. And to add to that, I will add, for example, the ethic angle and also the pseudoscience angle. For example, do you have some scientific proof that your hypothesis might be true? I have seen things like crazy. Like I saw once a system that was trying to predict like a credit risk, and one of the data sets was how the people move the mouse. I said, okay, what is the connection between moving the mouse and the probability of you returning a credit? And they say, so well, this is a hypothesis. Yeah, we can put hundreds of hypotheses that are not true. But even if they work, these are spurious correlations. They are not scientific causalities.
Yeah. Sandrine has a question. Sandrine, would you like to ask the question?
I can read it if she prefers.
Yeah.
Although it's nice to have some gender parity in the questions.
Yeah, I guess she wants us to read it. Yeah.
Okay, yeah.
So the question.
In your opinion, what is the best way to avoid that the increasingly spreading fake news get included in the data processed by the various language models and therefore get a kind of legitimacy? This is a big concern for fake news that are about scientific subjects, but not only those. Yeah, very good question, Sandrine. As I said, today will be the year of fake news. So more than 100 elections in more than 17 countries. Is the year that more people will vote on Earth, and fake news will be used a lot, and in ways that are much more sophisticated. Like this example, I think I mentioned this example for Hong Kong, where they fake a whole meeting online meeting. Like, who knows if Themis is real there? Maybe it's a fake Themis. I'm a robot, so, and I can say it because no one believes me. So, for example, I'm not a lawyer, so basically this is a policy question. But I believe that the only thing that works, because we have history about that, is basically what is the incentives to not do it, or what is the punishment if you do it. So if the fines are very large, then maybe people will not do it. And this is what happens, for example, in the banking industry. The punishments are so large that people, for example, finally are taking care of data privacy because the fines are very large. And this is the case of GDPR in Europe. But even the countries don't have an incentive to enforce this law. I mean, it was very well known that Ireland didn't want to enforce data privacy because they had all the multinationals, and they took years to finally fine, for example, some big companies because of processing European data in the US, for example. So this is not a problem only on the people doing fake news, but it's also a problem on the incentives that a government have to basically enforce these regulations. But we need regulations. One problem that the EU regulation will not really be in place until 2026. I think that's too long for fake news in political elections.
Okay. Are there any more questions? So let me just ask one last question. Would you like, Ricardo, to share with us some of the research directions that you are working on in this area?
Yeah, thank you. This is a question I like, but most people don't do it. So one of my research directions I'm really interested are these non-human errors. The intuition is that non-human errors are the ones that cause more harm. For example, blocking emergency vehicles, that's a clear harm. For example, not recognizing a woman crossing a bicycle. I'm sure that most humans, if you're not, say, drunk or with some problem, you will recognize a woman. Doesn't matter the light, you will recognize a woman and will stop. And the car was not going fast because these cars never go fast. So these are the ones that we are trying to recognize. So basically, we're trying to characterize non-human errors, and then trying to be able to find them automatically. For example, one simple case we published last year was that people may not recognize a type of cat or dog, but people will never confuse, for example, a dog for a cat. This could be dangerous, right? But systems do. So the state-of-the-art dog-cat recognizer that does like a 92, 93% accuracy, so it's very good. 3% of the mistakes are cases where they mistake the animal, and humans never will do that. So we are trying to look at that. Another direction in the same way, and also because we want to do harm-based evaluation. I think this is I mentioned it. I think evaluation is wrong. We cannot measure success. We have to measure harm. So, for example, obviously let's say the percentage of errors depends on the complexity of the instance of whatever you're trying to solve. So probably machine learning models are very good in simple cases and very bad in very hard cases. So the question is, what is the difference? Like, is zero error in these easy cases, and how much is in the hard cases? For example, the problem we use is face recognition in a crowd. Basically, if you have one face, never is a mistake. There's only one face in the picture, and it's right. But if you have 1,000 faces, you will have errors. You have 998, 1,001, whatever, depending on the configuration. So we proved that basically the system makes more errors as the complexity of the problem increases. And here it was easy to have a proxy for the complexity because it was the number of faces. But can we extend this to other cases? So can we extend human errors to other cases that are more complicated than recognizing two animals or more complicated than counting number of phases. So we are working on that. And the other, I guess, strand of research has to do with my team in Earth System, where I mentioned are my PhD students in Barcelona, is that we have a multidisciplinary team with 4 philosophers, so 4 ethicists, and we're working on the governance and how to put this in practice. So basically, it's a multidisciplinary research where we want to basically advise enterprise on the way to solve the problem of doing responsible AI by design. So this will be a goal too, but it's a much more ambitious goal.
Ricardo, I guess we are mostly talking about deep learning solutions.
Not necessarily. Not necessarily.
Yes. But I think that for the most part, this is the technology that these systems will be based on.
Well, but there's a bias. Sorry, but there's a bias there because most problems in the world cannot use deep learning because they have small data, and this is a bias we have in computer science, and because we're looking only at the multinationals that have big data. But 99% of the problems that we need to solve will never have big data. So it's not about neural networks. So
yeah, that's a very good point. I guess where I was heading at was the following. Do you believe that the solution to this kind of problems is to change the way that these models are trained, or the way that we architect these models? Or do we need the models themselves? Or do we need some external component that will try to regulate these models? For example, what you mentioned about the non-human errors. So can the model itself, whatever model this is, from traditional machine learning to deep learning, can the models themselves do that, or do we need something else on top of the model?
I think we need both. I don't think there's a single silver bullet. But for example, the model itself, this is what we're doing with one of my PhD students. So if we can predict if an input can produce a non-human error, and this is a different complexity of whatever the model is doing, maybe we can say, in this case, the prediction is that most probably this will be a non-human error, then maybe we shouldn't output anything. So we change the output based on these 2 answers. So, this will be a non-human error, then don't do it. So basically, you can censorship yourself of doing this. And of course, if this is the case, this model maybe will have less accuracy, but we have much less errors. And from the point of view of hand-based evaluation, it's much better. There's a colleague that jokes that, for example, he prefers to use a Buddhist car that will let you go to anywhere in the planet, but will take some time because will not kill any animal. While a Kantian car maybe will get very fast to the place where you want to go, but maybe will kill some animal in the way. And remember, humans are animals too. So this includes humans.
Okay, so thank you very much once again. It was great having you.
No, thank you for the invitation, and I can send you the slides later if people are.
It was very inspiring. Yes.
Oh well, but you recorded, so it's recorded, so no problem.
Yeah, right. Okay, thanks a lot. It was very inspiring. Thanks everyone that attended.
Bye-bye.
Bye everyone.
Bye, thank you.